Alright, let's talk about graphing trig functions. So here's our coordinate plane. I want to graph the sine function. We'll start off with that. So here are sliders to represent the values for the variables in the trig function. Since a and b are 1 and c and d are 0, we're just dealing with the sine of x, the function that is the sine of x. So over here I'm going to create my coordinates. First of which I will say will be, my first x-coordinate will be 0, and therefore since we're taking the sine, the y-coordinate is also 0. Then I want to do pi over 2. It converts it to a decimal, so the y value for pi over 2 is 1. If x is pi, y is 0 again. If x is 3 pi over 2, y is negative 1. And if x is 2 pi, y is going to be 0 again. So if I take these points and I create a list of points, it plots those for me nicely. And so hopefully that's what my graph should follow. So when I turn on sine, lo and behold, that it does. So I'm going to delete these. And this shows us the critical points, not the critical points, the key points for trig values, which would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. These are the north, south, east, and west of the unit circle, if you will, and the key points are the 5 points you'll need to graph any trig function. We can also say that the period of this function is 2 pi because by the time it goes through 2 pi radians, it starts over again. That will be important later. So what I want to do is graph a function where let's say that the d value changes. So I'm going to turn this off and I'm going to change the d value to 1, and we'll see what happens. And I have a calculator around here somewhere. Instead of using the computer calculator, which is not that user-friendly, I have my own graphing calculator, and I'll be using that. So you'll have to take my word that these values are true. So again, we're going to be graphing. I think I have a pen in here somewhere. Pardon my handwriting, but just for what we're working with, we're going to be graphing the sine, this is going to be bad, of x plus 1. Yeah, I'm writing with a mouse. I'm sorry. It's what I have to do because I don't have a tablet of any sort. So I'm going to start off with taking the sine of 0 using the 5 critical points. Key points, they're key points, they are not critical points. Because the slope is not 0. You will learn about that in calculus. Maybe you already have. So if I take the sine of x, which is 0, and then I add 1, I get 1. If I take the sine of pi over 2, I get 1, and when I add 1, I get 2. When I take the sine of pi, I get 0. I add 1, I'm back at 1. When I take the sine of 3 pi over 2, I get negative 1. If I add 1, I get 0. And if I take the sine of 2 pi and I add 1, I am back at 1. So I am going to create a list of points for this. This should be the pattern that the graph follows, and still in pen. Turn on the sine. There it is. Exactly what we wanted. Exactly what we predicted. And here is a more legible explanation of what the function is. These ones don't matter since they're being multiplied. They don't really affect anything. So all that matters is the sine of x plus 1. Okay, so that's interesting. Let's try the sine of x minus 1. So I'm going to turn this off again. So I'm going to change my d variable. Oh, let's do minus 2 for kicks. Why not? Okay, so if I take the sine of 0, I get 0. And if I subtract 2, let me subtract 2. I think I just pick on this and delete it. Oh, I don't want to do that. Delete that. If I take the sine of x minus 2. Alright, so the sine of 0 is 0. If I subtract 2, I get negative 2. The sine of pi over 2 is 1. Subtract 2, I get negative 1. The sine of pi is 0. Minus 2 is negative 2. The sine of 3 pi over 2 is negative 1. If I subtract 2, I get negative 3. And the sine of 2 pi is 0 again. So I get negative 2. And I'm going to create our points. When I say create points, what we're doing is we're creating a table of values, and then we are plotting the points. But in order to save time, I'm using a computer. We're going to turn on the sine function, and look at that, it matches up again. Great. So, is there anything that, the question is there anything that we can take away from this to say what happens when the d variable changes? Well, hopefully you can see that the d variable changes vertical shift. If I have a positive d variable, meaning that whatever is added to the end of this part, whether in this case it would be plus a negative number, whatever is added to the end of the rest of the function is going to be a vertical shift. If I have a positive 3 added onto the end, everything is going to be shifted up 3 units. If I have a negative 3, everything's going to be shifted down 3 units. So the variable at the end changes the vertical shift. And same thing works with cosine. The parent cosine function looks like this, where we start out at 1, then go to 0, negative 1, 0, positive 1. So in this case, if we had a d variable of 1, we would start at 1 on the y-axis, and everything gets shifted up 1. So, from y equals 1, we would have the regular function. Or if you're going from 0, everything gets shifted up 1. So since the first point of the cosine is 1, you add 1. Since the second point is 0, you add 1. Since the third point is negative 1, you add 1. Since the fourth point is 0, add 1. Fifth point is 1, add 1. And we're not dealing with this anymore. So, if I increase the d variable, the function goes up. If I decrease the d variable, the function goes down. Does that work? Nope. Okay. All right. So that is the d variable. Let's try messing with the c variable just by itself. So let's make it 1 to start out with. Now I'm going to, and actually no, I don't want to use 1. I want to use, because since I know what this is going to do, I'm going to use the variable pi over 2, which I know has a decimal of 1.57. So actually, let me change this. My increments will be 0.01, and so I'm going to move this to 1.57. That's about as exact as I can get on this. So now I'm dealing with the function. We'll go back to sine, because sine is used most often as far as science goes, because sine starts at 0. If you're talking about a pendulum swinging, that would generally start at something other than 0. But whenever people using this in the real world talk about this following some sort of pattern or some sort of curve, it's always the sine curve. I should say generally the sine curve. It's not as often the cosine curve. Anyway, we're taking the sine of the quantity of, in this case, x minus pi over 2. Now notice I have my c value is a positive pi over 2, but remember the function has x minus c, so this is going to be x minus our positive pi over 2. So if I put 0 in first, 0 minus pi over 2 is going to be negative pi over 2, and the cosine of negative pi over 2 is 0. The x minus, did I do that right? No, sine is negative 1. Let me try that again. If I have 0, 0 minus pi over 2 is negative pi over 2. The sine of negative pi over 2 is negative 1. If I have pi over 2 minus pi over 2 is 0, the sine of 0 is 0. The sine, or if I say pi minus pi over 2, that's going to be pi over 2, which ends up being the sine of pi over 2 is 1. 3 pi over 2 minus pi over 2 is pi. The sine of pi is 0. And 2 pi minus pi over 2 is 3 pi over 2. And the sine of 3 pi over 2 is negative 1. So here is my set of points that I'm going to now plot. And when I turn on my sine function, if I was in the button, all right, there we go. It matches up. Notice the key points that I had were shifted a little bit. That's strange, but hey, we'll just keep going and do a couple more examples and see where that takes us. Okay, so we'll turn this off. Let's use negative pi this time. So we're going to go negative 3.14 right there. So I want to delete this. I wish I could just delete part of it, but it's all highlighting at once, and I don't feel like figuring out how to change that. So I'm looking for the sine of x minus pi, right? Is that what I'm doing? No, since I am putting it into this function, we're doing x minus negative pi. So this changes to be a plus. So we're doing x plus pi. Okay, so if I put 0 in, 0 plus pi is pi, and the sine of pi is 0. If I put pi over 2 plus pi is 3 pi over 2. The sine of 3 pi over 2 is negative 1. If I put pi in, pi plus pi is 2 pi. The sine of 2 pi is 0. And if I put 3 pi over 2 plus pi is 4 pi over 2, which reduces to 2 pi. The sine of, what did I miss up? If I put 3 pi over, oh, that's what I did. 3 pi over 2 plus pi is 5 pi over 2. Make sure you can add fractions, that's very important. If you have 5 pi over 2, that is coterminal. Hopefully you know the term coterminal. It is coterminal with pi over 2. And the sine of pi over 2 is 1. And as I'm figuring this out, I have the unit circle pictured in my head. And hopefully you need to know the unit circle to graph. You don't need to. If you have a calculator, that works just fine. But knowing the unit circle works much, much faster. Okay, if I put in 2 pi, 2 pi plus pi is 3 pi, which is coterminal with pi. A lot of pi's going around, so the sine of pi is back to 0. I now want to plot these points. And list of points, okay, there is my plotting. And if I turn on the sine function, boom, there it is. Now again, the dots, the key points on the function itself have shifted in a strange way. So we will get rid of these points. Delete those. And now let's look at it. When our c variable is negative, now remember, this is x minus c. So if you want to think about it another way, whatever makes this quantity 0, this x minus c 0, is going to be your horizontal shift. So if, in this case, I have x plus pi, negative pi is going to be my horizontal shift. And if I had positive pi-ish, all right, oh, don't do that, 3.14, I would be shifted to the right pi units, where if c was negative 3 pi, I would be shifted to the left pi units. All right, what we just had. And it can be shifted whole numbers. That just makes computing a little bit more trickier. A little bit trickier. Because you then have to figure out what your critical points are. Essentially, you're always going to be putting in these points to the function, but if I put, for instance, pi, and if it was x plus 1, that makes it confusing. So a sort of way to get around this is, let's do this. I'm going to turn that off. and I'm going to delete this, and I'm going to say, let's do a new function, combining both of the new things we just learned, which will be the sine of, we'll say, x minus 2 and parenthesis plus 1. So what this tells me, I'm going to create a perpendicular line. What this tells me is that I'm going to have a vertical shift of 1 and a horizontal shift of 2. So a vertical shift of positive 1 and a negative, or a horizontal shift of, hopefully I said that right, a vertical shift of 1 and a horizontal shift of 2. Because again, this matches up x minus 2, this means a positive 2. We're going to be shifted to the right 2 units. So I'm going to put a point at 2, 1. And I'm going to say that this is going to be the center of my new graph. This is going to be where my new graph starts. Now from this new point, I would be able to, and I'm going to kind of guesstimate on here, I'm going to say that sine goes 0 and then 1 and then, come on, put a point there, 1 and then 0 again, and then, oh, terrible points, then negative 1, except that's going to be down there, and then 0 again. So I'm trying to sketch this. Bear with me as I do. Very sloppy work. You'll have graph paper, so it'll be easier for you. So once I can say that my graph kind of starts here, I'm essentially eliminating the minus 2 and the plus 1 in here. So I'm just working with the sine of x. And that tells me that it follows that pattern. And when I turn on sine, and I didn't put in my new function, so the sine of x minus 2 means my c is 2 and my d variable is 1. Now we turn on sine. Okay, kind of matches up if I was any good at saying, no, don't move that, this one. If I was any good at sketching points on a computer, that's what it would look like. So that kind of eliminates the tricky parts of putting just a variable or putting a number into the function and then trying to just figure out from there and solve for the next value. Because in this case, if I put pi minus 2 is 1.14. We don't offhand know what the sine of 1.14 is. So unless you had a calculator, you wouldn't be able to figure that out. But if you just say, well, I know I'm going to be starting at the point positive 2, positive 1, I'm starting here, there's my function. Same works with cosine. Since I'm starting here, the first point on cosine is positive 1, then 0, then negative 1, then 0, then positive 1. So when I turn on cosine, there's the graph that I have. Now it is off a little bit because the computer's doing rounding as we're graphing, and that will cause a little bit of variance, but you get the idea. Same thing works with tangent. I will get rid of, not both, just that one, yeah. Our C variable will adjust the horizontal shift, and our D variable will adjust the vertical shift. All right. So let's move on. Let us now worry about the let's do the A variable. So we're going to set C and D back to 0 right there and right there. So again, we're dealing with just the sine of x, but let's make it 2 times the sine of x. So in my pen, we're going to say 2 times the sine of x. 2 times the sine of x. So whatever the sine of x is, it's going to be multiplied by 2. So if I take the sine of 0 is 0. 0 times 2 is still 0. The sine of pi over 2 is 1. 1 times 2 is 2. The sine of pi is 0. And 0 times 2 is still 0. The sine of 3 pi over 2 is negative 1. Negative 1 times 2 is negative 2. and the sine of 2 pi is 0, and 0 times 2 is still 0. I'm going to create these points. Okay, so what happened here? Well, it seems like it got a little larger. I'm still on the pen. Yeah, okay. So it kind of got a little bit of vertical stretch going on there. That's strange. I don't know what's happening with that. But we'll keep going. So let's make it maybe -3 this time. So we're going to delete this function, and we're going to write a new one, and we're going to be working with -3 times the sine of just x. We're just going to be working with x here. Okay, so now when I'm finding my points, the sine of 0 is 0. In fact, I'm just going to go through and write these now, because 0 times anything is still 0. So the sine of 0, pi, and 2 pi are all going to be 0. The sine of pi over 2 is 1, and -3 times 1 is -3. And the sine of 3 pi over 2 is -1. -1 times -3 is +3. So now I'm taking these points and I'm plotting them. There it goes. Huh. Well, this time it got flipped and stretched. So that's what happens. Here's your equation right there. That's what happens with when you change the a variable. If the a variable was 0, you just have a line, because if you're taking 0 times the sine of something, it's just always going to be 0. And we're not doing that. So then let's do... let's take... So whenever a gets bigger, it's more of a vertical stretch. There are vertical shifts and vertical shifts and vertical stretches. The d variable is a vertical shift, and the a variable is a vertical stretch. If a is negative, it gets flipped. That would be something to make note of right when you start plotting this, or right when you start looking at the function. If your function is negative, it is going to have a vertical flip. So if a gets bigger, the graph gets more stretched. If a gets decimals, it gets to be pretty flat. If a is negative, it is vertically flipped, and the more negative, the smaller the a variable is, the more stretched, and you can't get more flipped, it's just flipped once, but the more stretched it will be. Okay, let's worry about our b variable. Now I'm going to also change this to have increments of 0.01. So now we're talking about this b variable outside. Okay, we are going to use the sine of 2x. So I need to change my b variable to be 2 right there. Okay, so the sine of 0, 0 times 2 is 0, the sine of 0 is still 0. The sine, pi over 2 times 2 is pi, and the sine of pi is 0. Pi times 2 is 2 pi, the sine of 2 pi is 0. 3 pi over 2 times 2 is 3 pi, and the sine of 3 pi is 0. And 2 pi times 2 is 4 pi, and the sine of 4 pi is 0. This seems to be an issue, because when we list all the points, that looks like it's going to be a straight line. Well, let's see what the graph looks like. Okay, yes, all the points lie on the graph, but what happened to the period? Now, the period is only pi, and that's different from what we were kind of looking for, or that's just different. That's just different. So, let us do another one. Let's say that we're going to delete these points, and let's say that it's maybe 4 pi. Or 4x, the sine of 4x. Oh, right. Oh, right there. Okay, so the sine of 0 times 4. Well, we'll just change our function. We're taking the sine of 4x. And so 0 times 4 is still 0, and the sine of 0 is still 0. Awesome. If I take pi over 2 times 4, that becomes 2 pi. Okay, and the sine of 2 pi is 0. Pi times 4 is 4 pi, and the sine of 4 pi is 0. 3 pi over 2 times 4 is 6 pi, and the sine of 6 pi, coterminal with 2 pi, is still 0. And guess what? The sine of 4 times 2 pi is going to be 0 again. This is strange. List of points. This is another seemingly line, but let's see what the graph looks like. And I need to be in the clicker. Okay, this one's even tighter. What is happening here? Well, when we change the b value, it's going to change our period. So, if I get rid of these, the equation that you need to know to figure out what your period is going to be is that the period equals 2 pi over b. So in this case, our period, let's turn on this because this is going to help. These vertical lines are going to be all the key points on the unit circle up to here, and then it keeps going. So this would be what, 9 pi over, no, not 9 pi, this would be 13 pi over 6, 9 pi over 4, 7 pi over 3, 5 pi over 2, this is 3 pi, this is 4 pi, so it just keeps going. We can see from this that the period of this function is just pi over 2. So if I'm saying that my b value is 4, 2 pi divided by 4 is pi over 2. And that's my new period. Now, what we can take from this, how we can figure that out, is we can say that since there's no shifts, we can say that our first point is going to be 0. And since we know the period to be pi over 2, we know our last point right here is going to be pi over 2. So if I take the middle between 0 and pi over 2, I get pi over 4. And if I take the middle between 0 and pi over 4, I get pi over 8. And if I take this one, the middle between pi over 4 and pi over 2, I should get 3 pi over 8. And here are my key points for graphing this function. So if I put 0 in, 0 times 4, the sine of 0 is still 0. This was pi over 8. Pi over 8 times 4 is pi over 2. The sine of pi over 2 is 1. This was pi over 4. 4 times the pi over 4 is just pi. The sine of pi is 0. This was 3 pi over 4, 3 pi over 8, I'm sorry, this was 3 pi over 8. And 3 pi over 8 times 4 should be 3 pi over 2, and the sine of 3 pi over 2 is negative 1. And this was pi over 2, so 4 times pi over 2 is 2 pi, and the sine of 2 pi is 0. Notice that once we multiplied all of these key points by 4, they became the basic 0, pi over 2, pi, 3 pi over 2, and 2 pi. So once I figure out the key points, I can just say, well, I know sine, since there's no amplitude. I should call this amplitude. A stands for amplitude, is the vertical stretch. So since there is no amplitude change, it just goes 0, 1, 0, negative 1, 0. 0, 1, 0, negative 1, 0. So if I made my b variable 3, then the period, if I take 2 pi over 3, well, that's just 2 pi over 3. So the period would take 2 pi over 3, which is not that. Yeah, that's 2 pi over 3. What am I thinking? Anyway, so 2 pi over 3, I'm thinking 3 pi over 2, which is out here, but it is 2 pi over 3. That is that period. If I wanted my b variable to be 1/2, so instead we're looking at the sine, where's my pen? The sine of 1/2 x. I would take 2 pi divided by 1/2. So my period should be 4 pi. So I'm changing my b variable to 0.5, which is right there. Well, look at that. My period is now 4 pi. If I made it 3/4 right there, my period, if my b variable is 3/4, my period would be 6 pi over 4, which is not 6 pi over 4. What am I thinking? Well, let's write it out. So if I have 2 pi divided by 3/4, that means I'm multiplying it by 4/3. So that's 8 pi over 3. So this is 6 pi over 3, 7 pi over 3, 8 pi over 3. There it is. So we can delete all this. So this is the equation you need to know. This is really the only thing that you need to memorize. Only as far as equations go, the only thing you need to memorize about graphing functions is that the period is going to be 2 pi over your b variable. Okay, so let's do a new function. We'll keep this here. We'll move it over here. And we're going to let's do cosine since we haven't done cosine. Well, let's look at cosine first. Same thing happens. If my b variable is 3/4, my period is 8/3. If it was 1/2, where's 1/2, right? Nope, no, stop that. There's my b value is 1/2, so my period is pi over 2. No, it's 4 pi. My period is 4 pi. If my b value is 1/2, if the b value was 2, my period would be pi over 2, or just pi, it'd be pi. If it was 4, my period would be, almost there, my period would be pi over 2. So they are inversely related, if you will. Again, same thing happens with tangent. With higher b variables, the more horizontally squished the graph will be. With decimal ones, it gets very stretched out horizontally. Very stretched out. Can I get it? Nope. Nope. I'm sure I could. Missed it. I was trying to get it on pi over 2, or I'm sorry, 4 pi. Can't do it. Anyway, let's talk about now, let's make a new function and graph it. So I want this to be at 1 right now. So we're going to take, let's do cosine this time, because we haven't done cosine. Let's take 3 times, let's make it -3. -3 times the cosine of, let's do, let's go over some. Let's say I want it 3x minus 3 plus 2. Now this doesn't look exactly like the parent function that I have already written. Again, remember what I said before, it's what makes this in the horizontal shift will be what makes this interior 0. Now if I factored out the 3, I would get -3, bad 3 times the cosine of 3 times the quantity of x minus 1. This is a little easier to see that our horizontal shift will be, again, +1, because it's what makes this 0. So our horizontal shift is +1, our vertical shift is +2, so I want to put a point at 1, 2. Put a point at horizontal 1, vertical 2. This is going to be the center of my graph. So there's my x-axis, here's my y-axis, right there. Okay. So I want to figure out what my period is. Next step would be to figure out my period. Now, since my b value is 3, I know that my period is going to be 2 pi over 3. So from here, from this point at 1, and actually, let's make this simpler. Okay, let's do a different function. Kind of similar. So it'll be -3 times the cosine of, I'm going to factor out that 3. I'm just changing it a little bit. We're going to say 3 times x minus pi plus 2. Okay, so this gives us a horizontal shift of positive pi and a vertical shift of positive 2. So I'm going to need a point at pi 2. So here is my new my new starting point. I just need an x and a y axis right there. So this is where my function is going to start. Now my period is going to be 2 pi over 3. So from here, I'm going to want to go out 2 pi over 3. So my first coordinate is at pi, and my last coordinate will be at, since my period is 2 pi over 3, 2 pi over 3 plus pi will be 5 pi over 3. 5 pi over 3. So we need to figure out what's in between those. And this is where the calculator comes in handy. So between pi and 5 pi over 3, so what I want to do is I basically want to find the average of that. So I'm going to take pi plus 5 pi over 3, and I'm going to divide that by 2, and I get 4.19, since we're doing rounding decimals. 4.19. The average between that and pi, I'm just going to add pi to 4.19, divide that by 2, and I get 3.67. 3.67, and the average between 4.19 and 5.24 is going to be 4.72. Does that make sense? Sure, that looks like right. Okay, now that I have my critical points marked, and my shift, and my period, and everything, the only thing that I haven't taken care of so far is the amplitude. So, since cosine, the cosine graph starts out at +1, now we're going to start out at -3, because 1 times -3 is -3. Cosine then goes to 0. 0 times -3 is 0. Then cosine goes to -1, but remember it's flipped. So now it's going to +1. +1 times, or -1 times -3 is going to give us a +3. So recap that. If I just want to take the -1 times -3, I get +3. If I want to consider it already flipped, then I'm starting out at +1, and then I don't need to take into consideration this negative. So 1 times 3 is still going to be 3. Cosine then goes to 0, and the last one at 2 pi over 3 plus pi. Cosine then goes to, under normal circumstances, a +1. +1 times -3 will be back at -3. So we will plot these points. List of points right there. Now, what did we not take into consideration? The vertical shift. So all of these points need 2 added to them. So this -3 turns into -1, 0, -1. 0 plus 2 is 2. 3 plus 2 is 5. 0 plus 2 is 2. -3 plus 2 is -1. So I would have noticed that after I plotted the points, and it's not sort of centered around these axes. Okay? Now, before I turn on the graph, I want to make all of these accurate. So my A variable is -3. My B variable is +3, right there. My C variable is pi, so I'm going to take this out to 3.14. right there. And my d variable is 2. And we did cosine, so I'm going to turn on cosine, and hopefully it matches up perfectly. That is just great. Okay, so I'm going to stop taking up so much time, and as a recap, the a variable changes the vertical flip and the vertical flip and the amplitude. The b variable affects the period. This is the only equation you need to memorize. The c variable affects the horizontal shift, and the d variable affects vertical shift. Now, there's one thing that I do want to mention very quickly, and then I'll be done, is that if everything is at 0 and my a is at 1, what happens, which we did not go over, we'll get these points out of the way, delete that, I want to get these crosshairs out of the way. What happens if b is negative? Well, in this case, and actually it will be more noticeable with the sign, if the b variable is negative, it gets flipped horizontally. So you're going to be mapping backwards instead of forwards. Same thing with cosine. You're mapping backwards. Now cosine, it doesn't matter, because if you flip cosine horizontally, it is the exact same thing. With sine and tangent, if you flip them horizontally, they do change. So keep that in mind. So this yields some properties that you can try and remember, that the sine, let's say, cancel, the sine of negative x is actually going to be the exact same as, so I'm going to show you something. So we'll turn off tangent. Turn off tangent here. The sine of negative x, which is just this, is going to be the exact same as, kind of remember where that is, it's going to be the exact same as the negative sine of x. Right there. It's the exact same function. So the sine of negative x equals the negative sine of x. Same thing with tangent. The tangent of negative x equals the negative tangent of x. And cosine is kind of cool, because the cosine of negative x equals the cosine of x. So those are some properties that hopefully you know. If not, if you did not already know, now you know them. So let's do the same thing with tangent. We'll turn off sine. Here's tangent with a negative a value, a variable, and a negative b variable is going to be the exact same thing as the negative a variable. Right, oh, I can't, almost there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there. Those are going to be the exact same functions. So there's some properties that will be good to know. This is the equation you need to know. You need to know these so that you could essentially modify your problem. So if you have a negative b variable, don't even worry about it. You can just change it to, if it's a sine or tangent, just change it to a negative function. If it's cosine, you can just get rid of it. It will not change the problem. Okay, if you have any questions, leave them in the comments. If you want this program, it's on GeoGebra. It's a free download. Let me know. I will email you this thing that I made. All right.